We have been learning about quadrilaterals in our math decoded. All four-sided figures or all four-sided polygons are called quadrilaterals. So I can have a shape like this. So this has four sides and this is called a quadrilateral. Now when we impose certain criteria on how these shapes could take, or when we impose some restrictions on a quadrilateral, we get different new shapes. So one among them was a trapezium, which we saw in our earlier video, where we imposed this criteria that one pair of opposite sides were parallel to one another and the other pair was non-parallel. So, and we called this shape a trapezium. We explored some properties of a trapezium and we also looked at a special kind of a trapezium, an isosceles trapezium. But in this video, we are going to impose another criteria that both pairs of opposite sides are parallel. When in a quadrilateral, if this criteria that both pairs of opposite sides are parallel to one another is imposed, what are the different shapes it could take? So let us see. Maybe one among them would be a normal one. So these two sides are parallel to one another and the other set is also parallel. So this is one possible shape it could take. These two lines are parallel to one another and the lines marked in red are parallel to each other. So, and we call this shape a parallelogram. The name itself indicates that we're talking about two sets of parallel lines. So this is the name, the parallelogram. So can this take any other shape? Now let's just explore. Maybe another possibility is here I have drawn a parallelogram in such a way that the sides are not so equal. They do not look equal in length, right? What if I draw parallel lines in such a way that all of them are equal? Maybe I'll just change the way it looks. So this way. So now I ensure that these sides are equal and at the same time opposite sides are parallel to one another. This set is parallel to each other and this set is also parallel. Of course, this can also be drawn on a flat surface like this. So this is, all sides equal. Approximately I have tried to draw all sides equal, and these two sides are parallel to one another. So this is one possible shape it could take. So this is also a parallelogram because it takes it follows this criteria, and this shape is popularly called as a rhombus. Now there can be one more way of drawing a parallelogram. This is also a parallelogram. Here the sides may remain unequal, that is these two opposite sides are parallel to one another and the other two sides are perpendicular to these sides which are already drawn. This side is perpendicular to the green side and this when joined, the endpoints when joined is also perpendicular. So this is also a parallelogram because it satisfies the basic criteria that both pairs of opposite sides are parallel, and this shape, as you may all are very much aware of, is called a rectangle. This is called a rectangle. And now there can be one more shape which is a combination of these two, that is all sides equal at the same time the sides are at right angles to one another. Yes, you would have guessed it. This is a square, and this is also a parallelogram because even here the both pairs of opposite sides are parallel to one another, right? I'll mark it in different color. So these two sides are also parallel to one another. So all these are parallelograms. A rhombus, a rectangle, a square, all of them are parallelograms because this condition that both pairs of opposite sides are parallel has been followed in these figures. Now in our upcoming videos, we are going to learn more about the properties of parallelograms and if there are any specific properties when they take these shapes, these different shapes, the rhombus, the square and the rectangle. So stay tuned. Thank you.